Somewhere in the Milky Way galaxy, space travelers might look for a star called the Sun and its lively planet, Earth. But where are they among those billions of stars? Until now, the maps for finding our way through the universe were faulty, like medieval maps of the Earth. Even directions were always a little wrong, and as for distances, they were mostly guesswork. All that's changed thanks to the European Space Agency's HIPPARCOS satellite. It has directly measured the distances to many thousands of stars. The puzzling sky is now transformed into an accurate three-dimensional view. Among these very luminous stars, the Sun stands out clearly only at close range. To check the navigation, look upwards in the northern sky for a bright but distant star. There it is, Polaris. It's aligned with the North Pole of the Earth itself. Using our new map, we can seek out the beautiful cluster, the Pleiades, known since ancient times. HIPPARCOS has plotted them in detail and tells us they are 375 light-years from Earth. Nearer home is a more scattered cluster, the Hyades. Seen from the Earth, the Hyades lie very close in the sky to Aldebaran, the brightest star in the constellation Taurus. But that's an illusion, says HIPPARCOS. In reality, Aldebaran is much closer in, at 65 light-years. Closer still are the twins of Gemini, Castor and Pollux. In imagination, we race through the light-years, but light itself, traveling at 1 billion kilometers an hour, takes hundreds of years to make this journey. Eventually, we can turn to near neighbors of the Sun. Procyon is just 11 light-years out. And at 9 light-years, Sirius. It's the brightest star in the Earth's sky, except of course for our own star, the Sun, around which we orbit. From another ESA spacecraft, SOHO, come the first clear images of the Sun among the stars. A mask blocks its direct rays. In the background are the stars and the Milky Way. As SOHO and the Earth move to the right in their orbit around the Sun's position among the stars shifts to the left in just a few days. In other stars, too, this shift due to the Earth's movements is detectable. It's called parallax. From slight changes in a star's bearings, astronomers can calculate its distance. But for any stars except the very nearest, astronomers have to detect changes in angle as small as measuring a golf ball across the width of the Atlantic Ocean, less than 1/1,000,000th of a degree. So Europe's astronomers conceived the HIPPARCOS satellite to fix the star's directions 100 times more accurately than from the ground. Weighing a little more than a ton, the spacecraft was very clever. Europe's aerospace industry built it for ESA. A special telescope in HIPPARCOS looked in 2 directions at once, separated by an angle of 58 degrees. Images of the stars from both directions came into the field of view of an electronic detector. As HIPPARCOS turned and stars moved across the field of view, they appeared and disappeared behind grid lines 1/100th of a millimeter apart. An image dissector sampled chosen stars repeatedly, signaling the data needed for fixing each star's position relative to adjacent stars and to those 58 degrees away around the sky. The brightness of each star was also measured. This scanner provided data on 120,000 stars for the highly accurate HIPPARCOS catalogue. Alongside the main grid, a simpler system of grids recorded the stars. This star mapper was installed to give immediate checks on the satellite's orientation in space, but it also created its own plot of 1,000,000 stars with somewhat lesser accuracy, the Tycho catalogue. Over nearly 4 years, HIPPARCOS scanned right around the sky 16,000 times. It visited each target star 100 times or more. In June 1993, the onboard computer suffered fatal damage in the Earth's radiation belts, but the mission had been accomplished. Multinational teams of astronomers then faced another 3 years of huge computing tasks on a million bits of information from HIPPARCOS. Here, the lines represent possible sky positions of one star as observed by HIPPARCOS over 2 years. The computer interprets them as showing the star moving across the sky by virtue of its own motion. The sideways shifts are due to the Earth's changing position in orbit and measure the star's distance at 90 light-years in this case. The diagonal distance covered shows the star itself travelling at 10 kilometers per second across the sky. Only then could the changing positions for the star go into the computations. The relative positions of every star had to match exactly all across the sky to straighten out any small wrinkles in the big picture. HIPPARCOS was still operational when comet Shoemaker-Levy 9 was discovered. Advanced data on star positions from HIPPARCOS helped in fixing the comet's orbit precisely and predicting its impact on the planet Jupiter in July 1994. Astronomers were able to plan exceptional observations of an exceptional event. From now on, all examinations and surveys of the wide universe will be keyed to the observations by HIPPARCOS. And all the telescopes on Earth and in space will steer with greater precision using the HIPPARCOS stars to guide them. Even more important is the grand harvest of new knowledge about the stars themselves. At first sight, their motions measured by HIPPARCOS seem to carry them in all directions. But some stars stay steady in the sky and are heading our way. This one will pass close by in 1 million years from now. Much farther away, other motions measured by HIPPARCOS reveal the dynamics of our galaxy. Gravity binds the most luminous stars close to the flat disk of the Milky Way. But the disk isn't quite flat. Outside the Sun's orbit in the galaxy are stars on slanting orbits. With HIPPARCOS, astronomers can evaluate a warp in the Milky Way, like the tilted brim of a hat. From many HIPPARCOS observations, scientists can create an image of this double star, and the stars are seen to shift during the few years when HIPPARCOS operated in space. From precise knowledge of the orbits, astronomers can deduce the masses of the stars and make their theories more secure. Another special prize from HIPPARCOS is the precise distance to the Pleiades. For star theories, the famous star cluster is important because the stars were born at the same time, about 100 million years ago. The Pleiades show astronomers how stars of different sizes evolve and age. HIPPARCOS finds the Pleiades to be 375 light-years away. That's 15% nearer than astronomers had supposed, and the stars are all less luminous than they were thought to be. So the theorists will have to think again. On the other hand, the stars of the Hyades open cluster are where they were meant to be, about 150 light-years away. The Hyades cluster as a whole is moving at 45 kilometers per second relative to the Sun. Plotted on a chart, the lines show the direction and speed of motion of each star across the sky. Stars traveling much too fast or too slowly cannot be members of the Hyades. But some other stars are drifting away and parting company from their clan. After 700 million years of gravitational stresses in the galaxy, the Hyades cluster is gradually falling apart. Due north from the Earth, Polaris beckons. But on our way, a small detour takes us to a special star, It lies south of the well-known stars of the Plough or Big Dipper. Astronomers search for other stars possessing planets, and they suspect that at least one planet tugs at 47 Ursa Majoris and makes it wobble. HIPPARCOS says the unseen companion is too small to be another star because the distance of 47 Ursa Majoris is just 46 light years. We can look back towards the Sun and see it as a modest star, not very hot. That's just as well, because modest stars go on burning much longer. A good deal more powerful than the Sun, but with shorter lives, are these stars of the Plough or Big Dipper. And Polaris in the distance is even hotter and will burn up more quickly. The distances of stars are full of information for astronomers. It turns out that the group of stars in the familiar Plough belong to a much larger swarm that surrounds the Sun. Although by tradition the Plough points neatly to the North Star for earthbound navigators, for interstellar travelers, Polaris is much farther away. By the HIPPARCOS route map, it lies 430 light-years away from the Sun. The many variable stars that flash and blink and flare across the ocean of space were prime targets for HIPPARCOS. Much farther even than Polaris in the northern sky is a famous variable star. Delta Cephei winks every 5 days. HIPPARCOS measured with great precision the pulse of a star that swells and squeezes itself like a beating heart. Delta Cephei is the prototype of the Cepheids, similar stars dotted around the sky. The bigger and more luminous they are, the more slowly they wink. For nearly 100 years, this Cepheid scale has been the chief measuring ruler for the universe. When the Hubble Space Telescope detects Cepheids in another galaxy, their brightness is supposed to reveal how far away the galaxy is. Yet before HIPPARCOS, astronomers could only estimate the distances to the Cepheids, even in our own galaxy. If the preliminary HIPPARCOS Cepheid scale is confirmed, all distances may have to be increased by 10%. That would make the universe bigger and older than astronomers have supposed. But it's a complex issue. It tests to the limit astronomers' understanding of the behavior of stars of all kinds, which depends on their sizes, ages, and chemical makeup. By its unprecedented precision and scope, HIPPARCOS puts the study of the stars on a much firmer basis. The release of the HIPPARCOS and Tycho catalogues by the European Space Agency in 1997 makes the route maps to the stars available for all the world. The harvest includes the discovery of 8,000 variable stars and 10,000 doubles never noticed before. It's a milestone in the history of stargazing and a highly original contribution by Europe's scientists and space engineers to the study of the universe. Experts and teachers will distinguish two kinds of astronomy, before HIPPARCOS and in the HIPPARCOS era. And so it will remain, at least until some future spacecraft fixes the stars with even greater accuracy.